Hi, hello friends. Welcome to the today's session. Welcome to Unacademy. Welcome to my classes. In this session, we are going to start transaction management. So, why transaction management? What are the functions of transaction management? We will look at into. Before entering into the session, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has provided a wonderful platform to serve the dedicated students. Use this opportunity to clear all your goals because your goal is Unacademy's goal. Dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with the various subjects, also had industry experience with a similar certifications. And throughout my journey of GATE, I taught in many premium academies with a high success rate. I'm also be proud that part of first and second rank acquiring. And dear friends, you also can achieve such kind of success just by giving GATE examination. And to clear GATE examination, there is a requirement of proper tips and shortcuts and experience, do's and don'ts from the senior most faculty members. So my sincere advice, those who are appearing for a 2021 GATE, write as many mock tests as possible which are conducting by Unacademy. And to get admission into Unacademy, you're having two types of programs according to GATE and ESE concern. That is a plus and the other one iconic. So once you become a subscriber either of this course like a plus or iconic, then you're going to see that unrestricted access from the Unacademy's portal where you can able to watch live sessions like quizzes, mock sessions and many other things. According to iconic subscription, so 1:1, this is a personal training, 1:1 personal coach. This is one of the unique program which is offering by Unacademy. And dear friends, according to the plus subscription, these are the subscription prices 12 months, 18 months, and 24 months by using my referral code. So, use my referral code to get the admission into Unacademy, and I will be grateful to you. And see that I am going to be act as your guide. So, throughout your examination. And dear friends, according to 12-month subscription, the current fourth year students opt for this, and the second and third year students can opt for 18 months. And first and second year, third year students can opt for 24 months super long term. And those who are giving 2021 GATE examination, if you're not yet subscribed, subscribe at least for 1 or 3 months course. Therefore, dear friends, you're going to have at least recorded lectures as well as mock examination which is conducted by Unacademy. And after applying my referral code, you're going to have these are the subscription prices finally. And according to iconic subscription, so two types, one is a long term and super long term. Current fourth years can opt for that. First and the second and third year students can opt for this. And dear friends, I use my referral code to get the admission into Unacademy. Therefore, we are also going to get a maximized concession on this. Friends, let's start the session. That is a transaction management part 1. So what is a transaction? Why we are learning a transaction management? What is a schedule? What types of schedules we are having? We will look at into in this session. So when you talk about the transaction, there is a logical unit of work that must be two things. Either it should be completed or it should be aborted. So transaction must not be in the hanging position or partial committed position. So no intermediate states are acceptable according to transaction. Dear friends, whenever transaction changes the contents of the database, then immediately it is going to switch over from one consistent state to another consistent state. So whenever you're reading a value from the disk, that is from database, it is called as a consistency. Whenever we read something from the buffer, then it is called as inconsistency. So due to inconsistency, there is a chance of conflicts. So let us see what is a consistent state and inconsistent state in the properties of your transaction. So when I call a transaction, you may say that whenever you do some kind of a banking transaction or online transaction or payment transactions, I can able to clarify these transactions in the following ways. So what are the different types of transactions we are having? We are having one is, if I do selection, it is a one transaction, nothing but I am performing a read. So when I want to do insertion and when I am doing updation and when I am doing deletion, so all these three I can call it as write. So basically there are two types of actions we will see in the database management system. One is a read action, the other one is a write action. Please observe. So write action I can able to talk in such a way that DML statements like insertion, updation, deletion, and read action is nothing but data retrieval language, which is nothing but a select action. So whenever you are performing some kind of action, initially the action is going to start from your database, which is available in the secondary storage device like a disk. Now whenever I perform some kind of activity here, like insertion, if I do, I'm inserting some data into your database. Therefore, what will happen? This value first of all are stored in the local buffers. If you are accessing from the local database, it is going to store in the local buffers. And after that, your database you want to affect, then there is a requirement of commit or abort statements. So after giving your either commit action or the abort action, then initially we started with a one consistent state, and after that we have reached at the end to another consistent state. So this is the concept, friend. This is your starting consistent state. After performing some kind of actions, I am reaching to new consistent state. This is your old consistent state and this is your new consistent state. Mainly transaction is always going to see that you're going to start from one consistent state. After doing some kind of a changes, we would like to reach to another consistent state. So this is what is the major objective of your transaction management. We do not want to see that any kind of inconsistency due to what? Due to these things that you're trying to keep the things in the local buffer. That means that the transactions is going to be in, what I mean to say, intermediate states. That intermediate states are not going to be accepted by your transaction manager, is one of the component of transaction management. Now let us see what is the consistency of the database. I already spoke about this. So it is going to satisfy all kinds of integrations which are applied onto that. You have to, whenever you define some kind of enforcement rules, and you need to satisfy all those enforcement rules while you are doing some kind of actions. So initially x is equal to 10, I am in initial state. Then after that I am going to modify x is equal to 100. The transaction is can able to do read, can able to do modify, can able to do delete, And finally we want to see that x is equal to 100. But this is going to be in a local buffer, please understand. As long as it is in a local buffer, there is a chance of inconsistency. As one of our friend is saying that there is a requirement of some commit statement or abort statement. So examples of a transaction is a deletion of the data or updation of existing records or insertion of a new records or any kind of action onto your database. Like a backup is also one transaction, like a recovery is also one kind of action. So every transaction is going to have two phases. One phase is that transaction must be begin, and another phase is that transaction must be end. Please understand. Every transaction actions are supposed to be in the block structure like a module, which supposed to have a start of the transaction, which supposed to have an end of the transaction, and the rest of the actions can be placed in between them. So for example, I want to say one example. So transaction 1, I started begin. Then transaction 1 is supposed to reach to end. I'm saying in the meanwhile some kind of insertion statements and some kind of updation statements. So as usually I say that a equal to 10 and we are keeping a is equal to a plus 100. Then I'm saying that w of a. Then after that t1 got committed. Then after that t1 got end. So this is how all the actions which are in for transaction 1 is going to be under this particular begin and end phase. Then after that another transaction will start. So it is saying that T2 start, and whatever action you want to perform you can perform. I say that R of A I can do, W of A I can do. Finally, if you are not interested, I can go for abort or rollback. And finally the T2 is going to end. So this way you can also say that the transaction T2 actions all kept in between begin and end phase. So finally every transaction is going to have a starting phase as well as ending phase. And if you end the transaction with a commit, you're going to reach to a new consistent state. If you are going to finish your transaction with abort, then you're going to reach to your old consistent state. So a new consistent state upon commit, old consistent state upon rollback. Why a new consistent state and old consistent state is coming, I will explain through transaction states. Now you listen. Any transaction whenever you begin, it is going to always active. If I am talking about a transaction Ti which has got all these states, every transaction has got a transaction state diagram like this. Now here I am talking about the transaction Ti. Whenever it begins, then it is going to be inactive. Then after that, you perform some kind of a read and write action. It may go to the partially committed. Upon the query is a success without any errors. It may be syntactical, it may be semantic errors. If query got failed due to errors or due to anomalies, then immediately you are going to reach to failed state. Then upon success of a query, you are reaching to partially committed. Due to errors, you are going to fall into a failed state. Then after some time, right now we are here and right now we are here. If at all the transaction got failed, then immediately it is aborted. Then aborted is reached to consistent state because the transaction got completed. Whenever a transaction got completed, then immediately it is going to reach to consistent state. Either it may be the old consistent state or it may be a new consistent state. Upon rollback, old consistent state you will reach. Upon commit, you are going to reach to a new consistent state. Now, let us see how the things are going to happen once we will discuss. So I'm going to talk about active, partially committed, failed, committed, aborted, completed, and consistent state. Now let me give you a small example on the transaction states. So 1 mark guarantee question, these basics, please learn properly. I say, let us start. Some salary value is equal to 100. T1 begin. When T1 begin, we are starting with the active state. Then after that, we are saying read action I am doing, salary, I got 100. Then transaction 1 continuing. This is a sequence number 1, sequence number 2, sequence number 3. I'm saying that a write off sal. So when I say a write off sal, then we are going to reach to something like 200, you assume. So I'm performing here some kind of update statements. So here I perform the selection statement. Now at the sequence number 4, the T1 is going to perform commit. So when you say commit, this is your old consistent state. So upon giving your commit, then you're going to enter into a new consistent state. So that's it. Finally, your value 100 is permanently is written with the new value, that is 200. So value got changed because I have issued a what? Commit statement. Soon after issuing your commit statement, so T1 reached to end. That's it. You got complete the transaction. Now I'm going to write some states. Observe carefully. So right now we are active state. So as you are performing some kind of a write actions, you are entering into your query is correct. Therefore you are entering into partially committed state. Then after that, as soon as you give the commit, then you are entering into committed state. And as soon as you enter end, then your transaction got completed. Then the completed transaction reached to consistency of the database. So this is how about the state diagram. So we have discussed in this direction active, partially committed, committed, then it reached to consistent state. Now I will talk about in other side. So this side I want to talk how the transaction is going to be aborted. Now let us see another example. Assume employee database has got employee number, and I say that this is the primary key which is already consist of E1 E2. Now I'm starting a transaction T2 at the sequence number 1, it is a begin. And at the sequence number 2, it started doing some kind of action that insert into emp, and I'm saying that values as E1. That's it. Then immediately as soon as you give this query, it is going to give you error. Why error? You know anomalies problem. So you cannot able to insert the same value in that as it is a duplicated. Immediately it is going to give you an error. Error in the sense your transaction got declined or a rollback. Then immediately T2 reached to end state. So what did we do? We did in such a way that you're initially active. This is talking about that you're active. Then after that, as soon as you give the query, it is a coming to a failed state because the query consists of some kind of errors or the query is going to consist of some kind of anomalies. Then finally, you entered into aborted state. And the third one I want to tell you in this style, please see. I'm saying as usually, let sal equal to 100. Now you tell me, I'm going to project this example, carefully observe. So transaction T1 is a begin, and transaction T1 is saying that sal is equal to sal plus 100. Then after that, transaction T1 is performing a write off salary. So we reach to 200. Query is correct. Initially we are in active state. Then after that we reach to partially committed. It's not a committed. First you will into buffer. Then from buffer you are trying to reach to the committed state. Now I say the T1 is going in like this. It is saying that roll back. So when you say roll back, then finally your T1 is reached to end. You know what is the value. I already told you, ultimately the main objective of transaction management is to reach the database to consistent state. Inconsistent state it is not going to accept. Inconsistent state in the sense it should not fall into partial committed, it should not fall into what failed, it should be either committed or aborted. Now according to that, what is the final salary value? So the final salary value you reach to consistency because as you have given a what? A rollback statement. So finally your salary value, as this is going to be cancelled, so your 100 is going to be restored for you. So finally we confirm that like this. Now you observe the state diagram carefully what I did. So initially I am into partially committed. Then upon given rollback statement, from partially committed I can able to do what? Abort. Upon partially committed, by giving a rollback you entered into abort, finally goes to consistent state. That means from partially committed you may reach to committed state, or from partially committed you may reach to aborted state. So this is what I want to mainly stress. Now I want to give finally one example. Please be ready. You give me answer to this. I say let initially salary equal to 100. So transaction 1 is as usually begin with a sequence number 1, and the sequence number 2 transaction is going to perform a write off sal. I made to 200. Then transaction 3 T1 is performing commit. Then after that transaction 4 T1 got, and after that transaction 5 T2 got a begin. Then after that transaction 6, so T2 is going to do a write off sal. It is making a 300. Then transaction 7 T2 is issuing a rollback. Then at sequence number 8 transaction T2, and now you tell me, after executing the sequence of transactions and actions, what is the final salary value? This is the question. So what is the final salary value? Is it 100, or is it 200, or is it 300? What is our answers? Is it 100, or is it 200, or is it 300, or it is a none of the above? Yes, exactly. Because so this is in partially committed, but you made it to committed. When you made it to committed, this 100 is overwritten with a 200, and that state cannot be changed because already you reached to consistent state. So when you reach to consistent state, there is no 100. Now your buffer value, earlier your value is in a buffer. Now your buffer value is reached to database. Now on this 200, now it is not 100. On this 200, we are making this and I am rollback. So rollback is going to take your value to 200. So this is how your transaction control language like commit and abort is going to work. Now let us see. So along with our transaction state diagram, transaction has got properties. These properties are called atomicity, consistency, isolation, and durability. Now these properties are called as ACID. So what is the meaning of atomicity? Atomicity is saying that transaction must be completed whenever you begin. It is not going to allow any kind of intermediate states. That is the meaning of atomicity. Therefore, either you do or none. That is the meaning of atomicity. And whatever the transactions you are doing, those entries are recorded in the log file that is called as a transaction log. So here log is going to act as a recovery manager in the event of the system got crashed. And now friends, let us concentrate what is atomicity. So it requires all operations either to be completed or to be aborted. So no intermediate states are acceptable. So that is the meaning of atomicity. And each and every transaction in the database will have a begin phase and a end phase. And specifying end of a transaction is a mandatory and begin is optional. This is an important point. Specifying end transaction is a mandatory but begin is optional because one end transaction is nothing but begin to next transaction. Friend, atomic is different and atomicity is different. So we know that whenever you specify end of the transaction which indicates the begin to another transaction. So for example, we are starting begin a transaction and now your information is being recorded in your log. Your information is being recorded in the log. So I am performing read of x and write of x, and write is taking a old value as well as a new value and on the which object you are trying to do action. And finally end transaction. This is being recorded in commit log. This is your begin log. This is your commit log. Now let me tell you one simple example. Is the following satisfies atomicity? So the example is like this. So transaction 1, it's a begin. Now we are performing as usually sal equal to sal plus 100. Then I am saying a write of sal and I left it. So when you left like this, so up to here only I performed sequence number 1 and sequence number 2 and sequence number 3. Is it satisfying atomicity? Please respond. Is it satisfying atomicity, dear friends? So we will say certainly not. Why it is not satisfying atomicity? In the sense I told you, whenever you talk about the atomicity such that either transaction to be completed or rollback. But here, as I am not doing any kind of a completion, because the complete actions are two. One is a commit, the other one a rollback. As it is not a committed, as it is not a rollback, then what is going to happen? If I start, let sal is equal to 100, will you tell me what is the salary value finally? What is the salary value finally? This is my another question. What is the salary value? Yes, friend, you're right. So as the end is not defined, therefore it is not following atomicity. And one more thing is that it is not issued any commit or abort statement. So it should be completed. Completed in the sense either you give a commit or a rollback statement. You want to end the transaction, there should be a commit log or abort statement. Now tell me, so what is the salary value in the sense? Then your salary value is 100. According to atomicity property, is 100 according to atomicity. Why according to atomicity in the sense, if you not do commit yourself, then the system is going to do undo. Then the system is going to do what? Undo. So here what is going to happen? The transaction manager, to ensure atomicity property, the default action it is going to take is a rollback whenever there is no commit or abort statement. So in such a case, the transaction manager component, whichever is there in your DBMS architecture, is executing here. It is executing here and say that as there is no end because there is no commit log, then immediately that transaction is going to be by force will be rolled back and you are reaching to the 100 value. So that's why it is not satisfying atomicity as there is no end and as there is no commit. Therefore, finally, the transaction manager to ensure the atomicity, it pull the value back to 100. And the second property is a consistency. So what is the consistency? As I told you, whatever the integrity constraints are defined before you start doing modification, those integrity constraints are supposed to be applied throughout your transaction. So in the schema, as well as any other constraints that should hold on the database. So according to this property, data in the database has to be consistent in the following cases. Number one, before the transaction as well as after the transaction. It should follow the constraints which you specified. So let me talk now consistency concept. I say salary is equal to 100. So I'm saying salary must not be modified. So when I say salary must not be modified, this is one of the condition I am holding. Condition on sal column. Therefore, throughout your transaction, you cannot able to do any kind of a modification to that. So that kind of a property, we are ensuring it is what? Consistency. And whenever you are switching your database from one particular state to another particular state, the state must be consistent. It should not fall into inconsistent. You want to see that end state should be a consistent in the sense you supposed to start your value reading or writing from consistent state. So you want to say that end is to be a consistent, you supposed to begin from a what? Consistent only. So when you start from consistent state, then you can able to easily hand over the state to consistent state. This is the point. So begin must be consistent. Therefore, it enforces that end is also going to be consistent. So either by using a commit or by using a what? Rollback statement. So I will give you one sample example on this. I say, as usually, I am taking a salary value and some transaction they are executing like this. T1 begin. When a transaction start its action, you see that whether you are performing a consistent read or consistent write or not. As I am taking the value from your database, I am perfect that I am in consistent state. Because whenever you do some kind of action from your database, then it is a consistent state only. Then I am doing some kind of events here. That transaction 1 is a continuing in such a way. So salary is equal to sal plus 100, and I am saying write off sal. Then when you say write off sal, this value where it will write in the buffer or a database, dear friends? This write action where it is going to keep in the buffer or database? Please respond. So whatever the value I have written, will it be in a buffer or will it be in a database? Please guess. Will it be in a buffer or will it be in a database? Thank you very much. Super. So it will be in a buffer. Now what is going to happen? So this salary is going to be under sharing. Now listen, I'm keeping here that salary is under sharing. When salary is under sharing, therefore some other guy, the T2, is begin there and is trying to do as salary is equal to sal plus 100, then he is also intentionally writing W of sal. Can you say what is the salary value now using this kind of a condition? So what is the salary now? The salary value is going to be now, as it is a 200 you reach, as it is under sharing, now this value it is going to reach to 300. Now you tell me, I have a question to you. What is the question? What is the question? A T2 performs consistent or inconsistent. Either it may be a read or write action. So T2 begins its transaction in a consistent mode or inconsistent mode. That's what is my question. T2 begins from consistent or inconsistent. So as I told you, you want to reach to the consistent state in the sense you're supposed to start from consistent state only. Yeah, thank you very much. So it is inconsistent. You're beginning yourself in inconsistency mode because you know what is the reason. What is the reason? The reason is that you are not starting activity from the buffer. You're not starting activity from the database. You're starting activity from where? Buffer only. So this is the final, friends. Whenever you are trying to do some kind of activity from your buffer, then it is going to be under inconsistency, and ultimately the result it will give you also inconsistency. So what I want to tell you here is that whenever you start consistent mode, then result may be inconsistency. Whenever you start inconsistent mode, the result would be always in inconsistent mode. So the thing is that whatever activity you do from DB, then it is a consistent, and when you do some kind of activity from the buffer, then it is inconsistency. So let us see the last property, that is called durability. So whenever you talk about the durability, so listen. So four properties we are having: atomicity, consistency, isolation, and durability. Yeah, you're right. Exactly, Santan Sharma. You're right. You're already experienced, man. You're doing very well. So now, as soon as you give, see that as soon as you give here, either the T2 is supposed to do either a commit or abort statement. In order to do T2 and if you not give a commit, then it is going to be aborted. And here also T1 is supposed to give either commit or abort because it is happening in some other place and this is happening in some other location. So if both are not giving any kind of a commit log, then it is going to be what? A rollback. Now let us see acid property whenever you talk, and these four properties are handling by two different components which are there in your DBMS architecture. One component is transaction management and another component is concurrency control, right? So transaction manager is responsible for atomicity and as well as a consistency as well as a durability, and concurrency control is responsible to implement isolation. Further you may reach to consistency. So these are the properties are being divided and they are sharing by these two components. Apart from that, there is a one more component is also called a recovery manager. So recovery manager is mainly looking of a durability property. So it is maintaining a durability property in order to further reach consistency. So three managers, three components in your DBMS architecture. One component is transaction manager and concurrency control and recovery manager. All together they are working in order to keep your database into consistent state always. So this is the association among three components: TM, concurrency control and recovery manager. Now I'm going to tell you about the fourth property, that is a durability. So durability is saying that if at all the system is under crash due to any kind of a problem like power failure or operating system failure, means DBMS cannot work as it is a software. Any kind of error or hard disk failure. These are all the reasons how your database is going to be under crash. So whenever database is under crash, then we want to recovery. That recovery is a concept of what? Durability. So it indicates the performance of the database consistent state. When a transaction is completed, the database reaches to consistent state and that state cannot be lost as it is already written to your database, even in the event of system failure. So whenever the system is under failure, you need not worry, you're going to get back those changes. For example, you see, in our mobile, we used to take some kind of a chart backup, or we are trying to create some kind of account in a Samsung cloud. That means what? Even your mobile is lost, you need not worry. All the contacts and your images and your files are going to be synced once again. So you're going to be get it. So you need not worry that your device is gone. So that's the meaning of what durability. I can able to recover my database even the system is going to be under crash. This is regularly happen in any kind of a client server architecture. Whenever the system is under crash, you need not worry, your database is permanently existed unless and until you delete it on your own. So the cloud backup, as one of our friend is saying, that's a real-time example. So changes made by the transaction should be permanent. Permanent in the sense it's supposed to be written into your disk using a commit statement, and finally it goes to the database, and finally it is going to store in a secondary storage device or a cloud storage, whatever it may be. So if the system crash, then all the active transactions during the system crash need to be aborted. So need to be aborted all the undone transactions. So which are not completed, those transactions we want to do what? Undo. So durability can be achieved by commit or abort statement. So DBMS component uh, ensures atomicity and durability is known as very important bit is a recovery manager. Recovery manager is nothing but to ensure a durability property, and to ensure this durability property you need to know whether the transaction got successfully completed or not. That information is available in Atomicity, that is a transaction log. So whenever you talk about the transaction log, which consists of a series of track of your transactions. So using the transaction log only, I can able to recovery when the transaction is not committed. So these are the different types of failures we have. A computer failure or a transaction error or local errors or exceptions. Concurrency control rules are enforced, hard disk failure, and physical problems. So whenever system is under crash, then recovery manager is trying to impose the recovery techniques and try to pull your values as much as possible. So it is going to recover your database to previous consistent state. So the recovery manager is going to use two statements, undo and redo. So undo is nothing but we want to roll back, and redo is nothing but we want to get back those changes which I need. So when are you going to do undo? We are going to do undo whenever it is a partially committed which does not have any kind of a commit statement. So whenever a transaction do not committed, then immediately the system is going to impose a rollback statement if it is under crash. Otherwise, atomicity will be proved. What is atomicity will prove? The system is going to keep end statement by just by doing a rollback. But exactly at that point, if at all the system got restarted due to crash problem, then the system would like to put it in the same state. That is what a rollback state only. So that is the point of what recovery manager. So let me explain with a small example. This is a very important question. Now you see. So initially there is some value here and the transactions are doing with a begin, and transaction 1 is completed. I am giving a log sequence number. Sequence numbers are very much important whenever you are doing some kind of actions. I am starting with the number 1, then number 2. So I'm doing as you say that sal is equal to sal plus 100. Then I'm saying at line number 3, write salary by T1. Then soon after you're saying write salary by T1, then 4, it is going to say that T1 got committed. And committed means we know the value it is going to take care is 200. And 5, T1 got end. This is your log transaction log file. This complete information is available in your transaction log, that however you started, however you reached to consistent state. This is known as a transaction log of your assume employee database. Now you see there is a one important point I want to tell you. So suddenly system got crashed. Point number 2, system crashed after sequence number 3. After sequence number 3. Now you listen. When the system got crashed, now there is a requirement of recovery manager who can able to do recovery of your database. But unfortunately, transaction manager cannot do this. Why it cannot do this? Transaction manager either can do commit or can do abort statement, but it cannot able to do any kind of functionality whenever you see a chance of what crashes. Then immediately transaction manager take the help of your recovery manager and to ensure the durability property. Now recovery manager will come and use this transaction log and try to keep your value to the previous consistent state. Now you observe carefully. This is your old consistent state. And when I say write off sell, I am into partially committed. It's not fully committed unless and until you give commit statement. I am partially committed. Then here I am doing a committed state. This is how your transaction log is written. Unfortunately, the system got crashed here. It started here and the system got crashed here. This is your crash point. Then immediately the recovery manager will come into the picture. It try to do three important steps. One is, now I'm talking one of the recovery technique which is imposed by recovery manager. You can do several ways, like a checkpoint is there, like Aris algorithm is there, like a shadow paging is there. So many other is there. I am using Aris as an example. We will learn separately about recovery manager later on sessions. Now, when you apply Aris algorithm, recovery manager is trying to recover your database. So soon after, whenever it is crashed, then it is restarting. Whenever it is restarting, it is getting collecting many number of information in order to do the recovery. So using a one kind of algorithm called ARIS. This is one of the famous algorithm which we are implementing in your RDBMS. What the ARIS is saying, there are three phases is mainly looking. First phase is analysis. What analysis is saying? Analyzing your log file and identify the dirty reads. Analyzing log file and identify dirty pages. So what is the meaning of a dirty pages? Active transactions at the time of a crash. That's the meaning of dirty, which are uncommitted. Indirectly I am saying that, which are uncommitted or which are not aborted. So this is also called as active transactions at the time of crash. Active transactions at the time of crash. Now, by seeing the previous example, can you say that which is a active transaction at the time of crash? What is the log number? The log number we want to identify that which is active transactions at the time of a crash means which is uncommitted. So which is uncommitted according to this transaction log file, we can understand that this is the one which is a active transaction at the time of crash. Exactly. So we understand that. So three. So that three is mainly we want. It also takes other sequence numbers also, but we are not going to take them because the partially committed one, this is only. So we understand that a log sequence number is 3, which is dirty because it is trying to write on the database, but it couldn't because before commit the crash has happened. And immediately this information will be transmitted to a redo. So what the redo phase is going to do, reapply the same operation once again. Reapplies the same operation once again. So however it was before crash, the same operation will be applied. So what is the operation it is trying to do? That is salary is equal to sal plus 100. Is trying to do that. Initially it is 100, is trying to manipulate to 200. This was to happen. So again it is trying to do redo. Then after that, finally undone. The third phase is undone. It is trying to execute. What is undone? Whatever redo is performed, that is going to be undone. So undone the action performed by redo. So this is how after doing undo, your salary value reached to your previous consistent state, that is nothing but 100. So this is how I can able to positionate that, how you can able to recover your database using three phases of ARIS: analyzing and redoing and undoing, three kinds of states. So according to that, I want to project an example here. You see, now I am taking the marks. Initially I got 50. Now the transaction is a begin, and it is trying to do some kind of a write off marks, nothing but update statement I am doing, and we reach to 100. Then T1 issues immediately committed. Then T1 need end statement. Then T2 begin it. Then T2 is also write the marks, object marks, how much it is writing. Now I'm showing exactly how the write operation will perform. So old value is 50, that is written by 100 and which is a committed. Therefore it is writing such a way, old value and a new value. This is how they are going to write in real time in your database. And finally T2 got committed, and finally T2 is going to end. Now I'm going to give you log numbers. So 1 and 2, 3, 4, 5, 6, 7, 8. These are the log numbers. Now this log belongs to student log. Now listen, system got crashed. System crashed after log sequence number 7. After log sequence number 7. So now he is asking which is a dirty page. This is the first question. Anybody? Friend, please give answer. So which is a dirty? Which is a dirty page or active page at the time of crash? As a crash is happened, after log sequence number 7 is written. And you, please answer. So this is a crash. Are there any active transactions at the time of crash? Are there any active transactions at the time of crash? So it is scanning complete student log file and checking for what active transactions at the time of crash. Are there any active transactions at the time of crash? Please answer. Are there any active transactions at the time of crash? Or which is a dirty page? Exactly, no. Now my question is, next immediately I want to ask a question. So which log sequence number to be redone and undone? This is my next question. Is there any requirement of redoing and undoing? Is there any requirement of redoing and undoing? Is there any requirement of doing any redoing and undoing? If it is the requirement, then tell me which log sequence number I need to do redo and undo. Exactly. So no. That's it. So what do we understand? As analysis scanned completely your student log, but it couldn't identify that any active transactions at the time of crash because they were committed before the crash event happened. Therefore, there is no requirement of any redoing and undoing. This is how the ARIS is going to work. Clear now? Now answer this question. Among the acid properties of the transaction, the durability requires that changes made to the database successful transaction persist. What is the answer? What is the answer to this question? Is it in the event of OS failure or is it in the event of system disk crash? Yeah, thank you very much. Any kind of error. Now, what is this? So there is some kind of a constraint is imposed that some of the accounts X and Y should remain constant is that of the constraint that the sum of accounts X and Y should remain constant is that of which kind of property it is? Atomicity or consistency or isolation or durability? Very nice. Now answer this question. You see that there are 7 log statements are there. So one is a T1 and the other one is a T2. T2 started at 5 and 1 to 4 is a T1 only. And B stands for a balance. M stands for mortgage payment. B stands for balance and M stands for mortgage. So initial value of your balance is at 12,000. We are pushing 2,000 from your balance to loan EMI, nothing but a payment or to mortgage. After remaining 10,000 I will get. So on the 10,000 bank want to give 5% interest. 3 different actions. One is initial balance 12,000. Push 2,000 from your balance to mortgage payment. Then apply 5% interest. This is completely talking into 2 transactions. One is transferring 2,000. The other transaction is applying 5% interest. The first transaction is for transferring amount to mortgage and the second transaction is for applying 5% interest. So exactly the database is crashed this point. Before log record 7 is written, the system got crashed. When the system is restarted, what is true according to recovery procedure? So you know three important steps: analysis, identifying a dirty page, redo, redoing the same action of the dirty page, then undo, undone the action which is performed by redo. They are going to be in a sequential manner. Analysis, then redo, followed by undo. Step 1, after that step 2, after that step 3. You cannot execute in a random fashion. So what is the correct answer? Which one is required to do redo and undo? Which one to require to do redo and undo? So write this sequence of transactions vertically, then you will understand. He is asking about redo undo only. So which action or which sequence number we should do redo and we should do undo? So we must redo log record 6 to set B to 10,500. Yes. So up to here, we understand your new value of your balance is 10,000, no doubt. So on this 10,000, we want to apply 5% interest. So your balance is going to be 10,500. Correct. So I'm writing a right action. The right action is taking like this. Exactly, I'm talking about this only. The right action it is taking like this. Right of your balance. Old one is at 10,000. Come a new one is at 10,500. Then after that T2 is giving a commit, but before commit that is crashed. So we understand that this is a dirty page, right? After doing analysis, we understand the dirty page is a record, the sequence number 6. And when you identify from the analysis that sequence number 6 is a dirty, this information will pass to redo. What redo will do? Reapply the same operation. What is that? Your 10,000 becomes 10,500. Perfect. But you cannot stop there. So you cannot stop there because we did redo in order to do what? Undo. So undo is also required. After doing undo, then you reach to your database to save state, that is called 10,000. Ultimately, we want to leave the value to 10,000, not we want to leave the value to 10,500. Therefore, so this is partially correct. And can you say any other answer apart from this? So any other option apart from A, which is a more suitable, which is a more suitable according to this property? Because analysis we do, then redoing. After redoing, we want to do undoing. Yeah, B after doing redo. No, but you see, option B is given that redo log record 2 and 3. Is it required? Log record number 2 and 3 is required to do redo. Is it requirement of log sequence number 2 and 3 to redo? So it is certainly not required. We want to see that set B to 10,000. Yeah, therefore this option is also wrong. Then option C. Can we prefer option C? Can we prefer option C? Yeah, that's it. So option C is correct. So it is not required 2 and 3 because transaction T1 has committed. Otherwise, you need to write that the law. We must undo log record 6, correct? We must undo log record 6, set your value to from 10,500 to 10,000. Up to here, this is a fine. But he added extension, na? So that extension is not required. That's it. So, dear friends, we will meet in the next session, that is schedule, serial schedule and concurrent schedule and conflicts of concurrent schedule in the next session. So stay tuned to Unacademy and stay tuned to my classes. If you're not yet taken a subscription in Unacademy, please take the subscription at least for 2 months, because you're going to get a very valuable things. And last 1 year recorded lectures are available. You may use them continuously, and you're also going to get many mock tests. This is a mock test time where you have to write many number of mock tests. Every mock test will give you a lot of confidence. So to get the admission into Unacademy, please use my referral code. I'm sincerely requesting you. Thank you very much. Yes, thank you, friend. And apart from ARIS, there is a checkpoint protocol. I will also give you clearly about checkpoint protocol in recovery techniques. So steel approach and no steel approach and checkpoint protocols I will discuss elaborately along with this ARIS algorithm in some other session. So thank you very much.